Anyway, people are slowly but surely joining. We've got 3, 6, 9, 12 people so far, plus the staff that are here. Oh, hi, Sydney. Hi, Sarah. And okay. Well, you're back now, huh? Very nice. Okay. Well, like I said, I'm just going to give people a chance to, get logged in. You're presenting to everybody. Okay, well, that's fine. That's what I wanted to do. And I'm recording. Yay. Okay, where am I? Here I am. Okay. Well, that was interesting. Some people just kind of snuck in. And so, it's funny. Sometimes you have to be admitted to these meetings, and sometimes you don't. Sometimes some people try and log in, and as soon as they log in, they get right in, which is, there's no problem with me. I'm not dancing around here topless or anything. I'm not too worried about that. It just surprises me when people can get in without actually being admitted. All right. So, like I said, we'll give people a couple more minutes to get logged in, and then we'll get started. I'm going to just jump over to our handouts and posts. So if you see this, don't stress out about it. I'm actually just looking down. I want to verify my notes that I made about our handouts and posts, because we're way down here to document number 24 is the biodiversity quiz. That's quiz number 19. And so that's 2.4. So document 2.5 is going to be on air resources. That's what we're going to talk about today. And document number 0025 is going to be quiz 20 on, water and air. Okay. All right, so we've got that set up here. I've got the quiz almost ready to go, and I'll get it posted after class today. And that is going to be the last quiz of the semester. All right, here comes Pablo. Hello, Pablo.
Hello. So quiz 20 is our last quiz?
Quiz 20 is going to be our last quiz, yeah.
Okay.
I don't know about you, but I'm tired of quizzes. Is everybody else tired of quizzes? Everybody's ready to be done with the semester and be off to Baja California to just hang out down there. Oh, no, that's not really. I mean, that might be fun. I'd like to go to the beach. That's where I would like to go. I mean, there's no beaches very close to my house, so I'd have to go probably to Rocky Point, which is one of my favorite beach places. But I don't even know if you can do that now. I haven't checked, but I kind of think that probably you can't go to Rocky Point right now. You have to, you probably can't. So I guess I'm just going to have to, pretend I'm on the beach or whatever. If we had Zoom, which I keep hearing good things about Zoom, how Zoom is a better presentation format. And one of the things about Zoom I've seen is that you can put whatever you want behind you. You can put a beach behind you. And I'd like to be able to do that. I don't think you can do that on Google Meet, as far as I know. I mean, I've been using Google Meet a lot. And there are probably features of Google Meet that I have no clue about, because all I basically can do is log on and do my best work on it. But I wish Pima would buy Zoom, which that's the thing, is that they haven't created a contract with Zoom that would let us teach on Zoom. But I'm not really sure what the great benefits of Zoom are, except I could put a beach behind me, or I could put a forest behind me, or something, just something different. I mean, I think I chose the absolutely most boring background possible. And I have not been able, with everything to do, to sort of put something better up there. I don't know. I thought after I saw how Caitlin had all this tie-dye, I thought tie-dye would be great. But I was afraid that if I sat in front of a tie-dye background, it might be just too much for me. I don't know if I could physically, spiritually handle it. It might just be too much. A beach would be fine, but anyway, who knows? Maybe in the future they'll do Zoom. There have been some developments in terms of things that they're planning to do at Pima. I think they don't have the summer session ready to even go yet. But I mean, people are enrolling. I'm scheduled to teach a class in second summer session, which you probably would not want to take because people who are in environmental biology wouldn't want to really take my cell biology class just because it's a whole different gig. I mean, I have had Bio 105 students who came to me and said, who have enrolled in Bio 156, and they were, I don't know how to put it, they were not pleasantly surprised because number one, there were actual exams, not anything like what we do. And there were also multiple quizzes, but they were not of the open note, open book, do it home, send it back quiz. They were the stand outside the door and feel like you're going to throw up kind of quiz. And so they were a little bit surprised to see a different side of Steve Mackey where I was much, had a different class. I mean, Bio 105, I said this the very first night when we met. I said, look, I like teaching this class and here's how I handle it. And if you would prefer to have anxiety-provoking quizzes and exams, then I guess I could arrange that, but I'd actually rather do it this way. So somebody's got their microphone on. Ariana, maybe I see you have your microphone on. Who else has their microphone on? Renee, you have your microphone on. If you wouldn't mind, just turn that off so we don't have to hear the, background noises or whatever. I thought it was so funny that this happened in one of my classes, and I told you the story. I told you the story how I was in one of my classes and, I was in the middle of a PowerPoint presentation or something, and suddenly I hear a toilet flush. And I realized that some student had was probably watching me on their phone and had taken the phone into the restroom with them. So we heard a really loud toilet flush. Well, then this happened last week in the Supreme Court. And it was on all, every one of the funny news channels was how during a Supreme Court proceeding, here was this lawyer just arguing very dramatically, and behind him you hear a toilet flush and you realize that somebody, probably a Supreme Court justice, was flushing the toilet and hadn't turned their microphone off. So it's not that unusual. I'm nowhere near a bathroom, which is a good thing. So if somebody flushes the toilet, we're not going to hear it here. What's crazy is that I don't actually use this, but let me grab something. Hold on, I'll be right back. Oh, sorry, folks. I know this is totally ridiculous, but I'm losing my mind. But, here's the thing. I have got these kind of things that I sometimes use them when I'm on a phone and I just want to get somebody off the phone, but I'm really tempted to use this during my lectures. Can anybody actually hear that?
Yes.
Very nice. Thank you. So I'm going to tell some kind of biology joke, like what's the difference between dirt and soil? Oh, well, soil is what you grow your food in, and dirt's what you wash your hand off before you eat. Thank you. Thank you very much. I appreciate it. The one I usually use when I'm on the phone is this one. Because I'll say to people, excuse me, something's going on outside. Usually that will get me off the phone pretty quickly. So if you don't have one of these sound machines, I thought there might be a toilet flushing, but there isn't. There's other. Perfect. Well, why haven't I been using this all semester? I don't get it. Especially this one. Yeah. Or even better. Now that's the one I need. Every time I tell a joke, I should have that ready to go. Like an audience. Thank you. Thank you very much. No, I need to stay away from that. It's too dangerous to play with those toys. But they're great things to have right next to the phone in case you need a reason to get off the phone, and you can make it sound like there's, bombs blowing up outside or whatever. Oh my gosh, this was made by Radio Shack. Do they even exist anymore? I don't know if Radio Shack even exists. I think they've gone out of business. All right, sorry. I really apologize, people, but after you've been sitting in a chair all day and you feel like you're starting to lose your mind, sometimes you just need to, chill a little bit. So anyway, now that everybody's here, or as many people as probably are ever going to be here, I am going to say thank you for coming to class. Okay, here's the thing. We've got a week more of class, right? And what that means is I'm going to do a serious lecture tonight. I'm going to do a serious lecture next time. But a week from today, I'm not going to do a serious lecture. I'm going to open class to meeting, and we'll gab. But what I'd like to do, actually, with that day, a week from today, next Monday, is I'd like to use it, if I could, for individual grade meetings for people who want to look at their individual grade, okay? And so I am going to be just busting my get everything graded and recorded so that by Monday you will know exactly what your grade is. And believe me, I know for a fact there's going to be a lot of A's, and those people who have A's in the class, well, you could come to class that night and you could just say hi or bye or whatever, and then be done. And the rest of the time, I'm going to devote it to people who I need to talk to about, assignments and things like that, so that I can help them maximize their grade. Okay. So that's the plan for a week from tonight. Okay. So bottom line is that I've got two more real class days. And that includes tonight, and that includes Wednesday. But then next Monday, again, I would love it if you would come and just show up briefly and say, Caitlin, do you have a question?
I do have a question.
Okay. Involve this? No? Okay.
I mean, a little bit. I need to know where you got it, but
okay. I got this one at the Dollar Tree, believe it or not.
Cute. Okay. I'll get one.
No, who knows? I bought them all, I think. But anyway, go ahead. Sorry, Caitlin. I apologize.
Don't be sorry. My question is, do you think our lab summary and all that will be graded by next Monday?
Oh, yes, absolutely. Everything will be graded by next Monday and recorded. Okay?
Okay.
But,
thank you.
The thing is, I mean, I could be wrong about this, and I doubt if I'm wrong. But, between now and then, if people get turned in whatever they can, I should have absolutely semifinal grades that night. And honestly, I would be astonished, just between you and me, because I've been teaching a long time. If you went and looked at your D2L grade right this moment, that grade is probably almost accurate for everybody. But there are people who owe me things and might want to try and get some of those things to me. I'm as flexible about this stuff as you can possibly be. I've warned you before, do not ever expect another instructor of yours to be as, I don't know what the word is, generous as I am when it comes to turning things in. If you have things that you can turn in of any kind, old quizzes that they're down the bottom of your backpack somewhere or whatever, just rub some Purell on those, fill them in and send them, right? The bottom line is that I'm still willing to take that stuff. The maximum penalty I impose is 25%. So I'm just saying, if you still owe me stuff, don't despair, try and get it to me. There are many people who don't owe me a darn because they have turned everything in on time. And those people, I would say, most likely, if you look at the actual data on D2L, you'll see that those people have an A already, and they're likely to retain an A if they just finish turning in the stuff there is. Now, I don't think this is on the PowerPoint because it just didn't make it on the PowerPoint, but I'm giving one more quiz, and that's it. I'm overwhelmed by grading. I'm giving one more quiz, and that one more quiz is going to be quiz number 20, and it's going to be on these last two PowerPoints, one on water resources that we're this close to finishing, and one on air resources that we will get started on tonight. Then the last quiz is going to be information from both of those PowerPoints, okay? And then that's going to be the last quiz. Now, that does, for what it's worth, create 5 bonus quizzes. And that means people are very likely to, do pretty well if you just make sure that you get me that stuff, okay? So, so go ahead. If you owe me anything, get it to me as soon as you can. I'm behind on grading, of course, and I feel really bad and guilty about that. My general stat, as you know, because remember a couple of years ago when we first met at PMA, you saw that I like to get things graded and get them back. Those grades, that's been my style for many years, and this kind of thing where I'm just sort of buried in a mountain of grading and I trouble breathing sometimes, then that's definitely not something I enjoy doing. I'm going to figure out how to make that less burdensome on me. My plan is to win the lottery and then hire an assistant to grade everything. But barring that, I've got I think there are other better, more efficient ways to grade. So bear with me. I apologize. As I said, I feel really guilty about it, but I'm working my best and we'll get it together. Believe me, nobody is gonna end up without a grade that they're happy with at the end of the semester. And it's funny how fast the end of the semester is.
Mister, I also had to tell
you. Go ahead.
You graded, I sent you my quiz 10 and 11 both together in an email. And then you posted my grade for quiz 11, but you never posted the quiz 10, but you told me that they're both, like what the grade was on both of them. But I emailed you and let you knew,
right.
So you should see it.
Oh, you emailed me about it? Thank you. That's the best thing to do.
So if you see it, yeah, you just got to.
Thank you.
Thank you.
Thank you. And so go ahead. Thanks for doing that. I'll get that corrected. No doubt about it. I will get that corrected. Okay. So one more person just logged in. Great. I am happy. In the normal semester, pre-COVID-19, this would be one of my favorite days because people would be doing presentations. And I love it when people do home ecosystem lab presentations at the end of the semester. And I don't know, maybe in a future Bio 105 class, I figure out how to do those presentations on Zoom I can sit there and watch people do or not on Zoom, Google Meet, whatever. That's not what's happening this time. So I am looking forward to seeing people's data summary, those things that are due. Let me open up the PowerPoint that does have class business on it. And again, if I sent you an email that said, okay, I graded these 2 quizzes and here's the grades, and then somehow those didn't appear on D2L, well, those are the kind of problems that have to be dealt with. They will be dealt with, and you should not stress out about them. Just let me know, and I'll get them dealt with, because honestly, that's always true at the end of the semester. There's always, grading things like that just need to be dealt with. I have to turn in grades. I think that the official date for turning in grades is like the 22nd, which is a week from Friday. And believe me, I'll get all stuff done. But, a week from today on Monday, people will know pretty much what their grades are. And so they'll be able to either say to me, Steve, I'm happy with that. I'm out of here and I'm off to sneak through the border and get to Rocky Point and get to the beach. Or I really would like to talk to you about what I can do to, what do I still need to give you in order to push my grade up to a place where I'd rather it was. Okay, so that's a week from today. Between now and then, I am going to force you to sit through 2 more real lectures and PowerPoints, and I will post that stuff and everything. What I was saying earlier today is that I'm going to post as document number 0024 the PowerPoint that I show you today. It's not posted yet. It's called Air Resources. And then I will also post the last quiz number 20. It is document number 0025, and that will be a quiz on water and air based on the last 2 PowerPoints and stuff that we've covered. Okay, so that's the basic plan. Now, I got to reduce myself for a minute and get over here to sorry, and these are a little bit crude. There are things I need to work on these, but this one, Course Lecture 12, continues tonight. It is already posted. So what I wanted to do is go to class business here, and even though this says Coronavirus Lecture 12, and it should say Coronavirus Lecture 13, oops. And I change it here to May 11th, 2020. Like I said, this water resources PowerPoint that we're looking at now is posted as document 0023. The biodiversity PowerPoint, which we're long past, was posted as document 0019. My YouTube posts, I think I've uploaded everything recently. Right down here, I'm going to completely remove this one. That's old news. I'm going to redo this. I apologize that I'm doing this, but I'm going to redo this. And this is going to say quiz 20. Whoops. Can't even spell water. I'm going to get that posted, and I'm going to make that due on Wednesday. It'll be posted today, okay? Water and air, it's going to be due Wednesday, May 13th. Uh-oh. It's Wednesday the 13th. Okay, so be careful. Tonight's topic is water resources and air resources, even though PowerPoint says it says air pollution. There is a portion that's about air pollution, but then there's a portion about just plain old air. Good old air, the stuff we breathe every day. And then I answered this question a minute ago, and I'm happy to answer it again, but That Home Ecosystem Lab summary sheet technically due today. If you haven't gotten it to me, then get it to me as quickly as you can, right? I mean, I'm behind on looking at all that stuff. All right, so I modified this so it looks a little bit more up to date. Anyway, all right, so what else is there? So there's quiz number 20, which is going to come at you. It's going to come at you today, all right? And then let's see if that works. Probably not. Nope, didn't work. Sorry. All right. Got to undo that. Sorry, folks. I apologize. All right, here we go. So, anyway, if you have a question, of course, please immediately just open your mic and ask me the question. That's the plan right now, okay? And or you could put it on the chat. I don't know. I see some new chatty stuff here. And maybe they want me to take the quiz online. Are you talking about quiz number 20, Caitlin? The brand new quiz that's not even posted yet?
Oh, I was just replying to Ariana.
I see. Okay.
Yeah,
that's right. There's every living thing. I mean, look, if all you have is, say, 200, don't stress out about it, right? And I know there's people who've been sending me that they've got like 1,000 living things in their house, but I'm only kidding.
Yeah.
Of course,
I
would. Go ahead.
I had trouble with that. I just couldn't really. I don't know. Like I couldn't find that many, so I really don't have too many.
Really? Well, how many do you have?
Like 12.
Oh, and that's okay. That's your 11 cats and your dog?
No, yeah. I put my animals, so those are my only animals, just because I don't eat meat, so
right.
I didn't have anything.
I'll bet you your pets are happy that there's no chance, despite the virus, that they'll get eaten. I'm happy about that.
Yeah.
The bottom line is that this was an exercise, right, in you thinking about the living things that you find in your house. So I mean, one example I gave, and I mean this is kind of late probably, is I said salsa, right? Salsa. Well, in salsa, I'm just going to think about it. There's tomato. That's one thing. There's garlic. There could be cilantro. There could be one or more kinds of chilies. There's certainly, I'm going to do this right. Tomato, vinegar, chili 1, chili 2, cilantro, tomatillo. Some chilies have corn. Some have beans. I mean, it's possible that in a single jar of chili, a single jar of salsa, there would be 5 or 6 different living things in one jar of salsa. A bottle of ketchup probably has 3 different living things in it. You see what I mean? That's why I was saying, if you look at your spice rack and you see oregano, cinnamon, cloves, nutmeg, rosemary, garlic. I mean, in my spice rack, I probably have 10 different species of living things. Now, are they living now? No, they're dead, but they were alive, and now they represent living things that are contributing to my home ecosystem. So, I mean, if you had cheese, then you would have a living thing there, right? Because it represents a cow. It represents milk from a cow. If you had tofu, let's just say you're a vegan, then you probably eat tofu products, or maybe you eat yogurt, or no, I guess you wouldn't eat yogurt if it was tofu, unless if you were vegan, unless it was like cashew yogurt or coconut yogurt. I mean, I see all these different kinds of yogurts. Anyway, the bottom line is, even if you're a vegan, I would be, okay, look, Tell me where you live, and I'm going to come and look in your refrigerator, okay? And I'm just going to see how many I can find. And if I can only find 12, well, then you'll be fine. You won't have to repeat this class next semester. But anyway, I'm just kidding. I'm hoping that when you looked through your house, you were thinking about, different living things that could be in your house. I mean, I was only joking about 100, but I personally think if I just wandered around my house here, I could probably find, just by looking in the refrigerators, I could probably find 25 different things in my refrigerator alone. But don't worry, I'm not going to stress out. If you give me 2 things, that's all, well, then I may think that's too few. But anyway, bottom line is that that data technically due before class. Am I stressed out about it? No, get it to me ASAP. And, don't run down to Sprouts and buy a bunch of living things just to include them on the list. Okay, so don't do that. All right, any other questions? I'm happy to answer questions. And I should never, okay. Oh, okay, so you're asking me, wait, you probably answered this. No, I'm happy to answer it again. The question is how do you calculate the percentage, okay? And hold on, let me answer one question at a time, Carol. I'll get to that. So first, let's just think about percentages. Okay, I'm going to go down here and say, let's just say that in your house you had 4 fungi. Okay, you had portobello mushrooms, you had shiitake mushrooms. You had portobello mushrooms, shiitake mushrooms, straw mushrooms, oyster mushrooms, and bread mold. Okay, so you had 4 fungi. So you had, no, let's say 5. That might be easier. We had 5 examples of fungi, all right? And when you added it up, you divide it by the total number of living things. So let's say in this case, that was 20. 5 divided by 20 equals 0.2, right? Which your calculator will tell you that. But then you're going to multiply it by 100 to get a percent, and that equals 20%. Okay, so if you had 5 fungi divided by the total of 20, then that's 20%. Let's say you had 10 different plants. Well, 10 divided by a total of 20 would be 0.5, and 0.5 times 100 is 50%. So that's how you calculate out the percentages. It seems pretty straightforward. But the kind of numbers people have, eventually you got to total it all up. Did that answer your question, Sandy? And then I'm going to, okay, good. Work on that. And then, oh, sorry. Gosh, I didn't post this. Duh. All right. They should, on one of those little boxes, they should have people booing. All right, so Carol, I'm going to go back to your question. Quiz number 15 was on ecosystem services, and the PowerPoint that dealt with ecosystem services, I'm pretty sure was PowerPoint 0011. Okay, but I'm going to check it because that is within my capabilities as a master of technology. I think I can check this out pretty easily. Just have to find it. Here I was so busy congratulating myself on being a master that I totally revealed that I was in fact not a master. Oh, maybe I'm wrong about that. Ecosystem community ecology. Let's see if it's here. No. Oh, yes, it is. Ecosystem services. So this is actually document number, can't read it, it's over on the edge. Oh, 008. So let me write that down, because here's all the stuff on ecosystem services that we covered. Yay, and that was 008. So I'm going to go back to wherever the heck I am here, move myself into position. Uh-oh, I just killed that PowerPoint, huh? Carol, I'm going to answer your question, which was 008. Okay. Quiz number 15. Oh, wait a minute. Yeah, quiz number 15, ecosystem services. So quiz 15, equals PowerPoint 008. Okay. There you go, Carol. There's the answer to that question. All right. Well, I'm sorry to say we're out of time for tonight. That was a joke. We are just getting started. But I'm happy to answer any questions. Just jump on in and ask away if you have a question. Now, what did I do to that PowerPoint? Here I was. So, again, I just updated this PowerPoint. Where I want to go is page 44. So, remember, we talked about water and all kinds of stuff about water. Now, water has been kind of a big topic for us, and it should be. I mean, look, if you live in a desert, then I think one of your big topics should be water. Okay? It really should be water. We live in a city that works really hard to make it seem like we don't live in a desert. Maybe you remember when you watched that American Nile video, and they were talking about how when they tried to get people to move out west, they told them they were going to give them free land. Come on out, and we will give you free land, and this, we'll get you set up. We'll give you free land. You can build yourself a house and all that. I mean, it was free land in the West. And what they didn't tell people deliberately was that there really wasn't much water out here. That the normal kind of processes that people used to get water, whether it was getting water off surface waters or drilling not too deep well to get water, those processes probably wouldn't work out here. But I don't think they wanted people to know that. And that's what they said in the in that Cadillac Desert American Nile video. I mean, it was kind of like, hey, we encouraged people to move into an area where water is scarce, but then we tried to pretend that it wasn't scarce. I mean, we put fountains in, we built lakes, we did all of this stuff that suggests that we don't live in a desert, that somehow there's an infinite supply of water out there ready to go. Well, just in the newspaper the other day, there was an article about the Colorado River and how a very low level of rainfall in April was really threatening the Colorado River flow, and it was a pretty serious concern about whether there would be enough water to distribute water where it's supposed to go. And we shouldn't really worry about that because we only get 2/3 of our water from the Colorado River. And so if they took away the 2/3 of our water, well, then, the city of Tucson would dry up and blow away. Though it seems as if you look at what's really going to happen is that if the water gets seriously low, they're going to take it from farmers first. And they'll leave it for us, but they will certainly start instigating some serious conservation practices, okay? Which is why I stopped here the other night. This was an article in the newspaper on Friday, I think, where they were expressing concern about water flow in the Colorado River, which, again, some people moved to Tucson. Well, I moved to Tucson in 1977, and I was told, look, don't get used to Tucson. You're not going to live here, because it turned out that many graduate students, myself included, who came to Tucson, kind of fell in love with Tucson and then decided to stay here. But when they finished their degrees, they could not stay here. So it was really typical pattern. They would say to people, look, don't get used to Tucson. As nice as Tucson is, good things about Tucson, don't stay here. You won't stay here because in order to finish your degree and to earn a living, you're probably not going to be able to stay in Tucson. Well, I ended up getting stuck in Tucson and getting a great job at Pima Community College. I couldn't be happier in the job that I'm in. But anyway, the bottom line is that maybe there's people in, here in class that are just like, I'm going to be in Tucson for a year or so, and then I am off to Portland or someplace where they have plenty of water. But if you plan to live in Tucson for an extended period of time, maybe the rest of your life, then I would be worried about water. So if you need more water, one way to get more water is to conserve the water that you have. Don't waste water. And what I was just saying is, here's the Tucson Water Plan. This is what they publish as their basic plan, and it's supposed to cover us from 2000 to 2050. So we're not halfway there even. And all I really want to show you is that they're predicting that the population of Tucson, which has been pretty steadily growing, and is going to see, this line right here is total demand, which means population, right? And notice it's growing. Okay, here we are right here in 2020. According to this, the population is slowly growing, and it's going to grow and grow until it hits this weird place in around 2030, 10 years from now, where it's going to kind of stop growing and just level off. Well, it's hard to know why that might happen. Somebody is predicting that's going to happen, and maybe it will. Who knows? Maybe the population will not even continue growing until 2030. Maybe it'll level out. But if this is the demand right here, then what we want to do is take a strip right through the demand and look at where the water is going to come from. A portion of that water, they're saying, is going to come from reclaimed water. And when you read what they mean by that, they're basically mean water that they're able to, they'll be able to reclaim once it's been used, clean it, and reuse it again. And that's certainly entirely possible. I mean, look, I will show you in just a little graphic that kind of illustrates what they call a toilet to tap system, where you take toilet water and you clean it, and then before you know it, you can actually drink it. There are many places these days that literally have, they're like wastewater treatment plants that have a drinking fountain on them. So you come and drink the water, and they go, what do you think of the water? And you go, oh, it tastes delicious. And they go, well, that was in somebody's toilet, I don't know, yesterday maybe. And but water is water. Water, good old H2O, is an immortal molecule in most respects. And when you ruin water, you either pollute it, and most of the time you can unpollute it. It's expensive. If they can desalinate water, then they can take salt water and make it drinkable water. Well, then you can take polluted water and in most cases make it totally drinkable water, even if it has some serious pollutants. Okay? So that's one possibility. But the other possibility, of course, in a city like Tucson that most people don't seem to think about is that, if we put water in the atmosphere here, it doesn't stay here. So see, if you're doing some water practice where you expose the water to the air where it can evaporate, remember that we get on the average about 12 inches of water a year. But we evaporate 60 inches of water a year, right? And so if you let water be exposed to the air, you can kiss it goodbye because it isn't going to stay here. So this is water that they're basically saying, I'm just looking at us right here in 2020, they're saying this is water that we actually are going to retain and we're going to treat it. make it usable again. Now, this blue bar right here, this is groundwater. So they're planning to continue to pull water out of the ground. And notice this is a pretty standard amount, right? They are, right now, in 2020, they are expecting they can still take groundwater out in a sustainable way, which means what? They're not water mining. They're making sure that they put much water back in as they take out, because there's laws against water mining starting in 2025. All right, but then let's just follow the line up, because here it is. You see this big giant block here, which I don't know. I do think this represents about 2/3 right here. This represents about 2/3. I mean, we can look at the actual numbers and go, okay, 200,000 acre feet, okay, and there it is. 200,000 acre feet is what they're is what they say we need, and 100 and stops out right about here. It's going to go over to here. So let's just be generous and say that's 140,000. So 140,000 divided by 200,000 is 70%. So that's more than 2/3. More than 2/3 of the water is coming from where? Well, look, it's Colorado River water. This is Colorado River water, which, I mean, again, is the Colorado River a good, sustainable, constant, reliable source of water for Tucson? I would say no. That this could be kind of a pie in the sky, because everything that we hear about the Colorado River isn't really good. I mean, all you have to do is go and look at Lake Powell and see that it's only half full, or go to Lake Mead and see how shallow it is compared to what it was in other years. You know, I'm not saying this is going to happen, but some people have predicted that part of global warming is going to result in a pretty severe drought here in the U.S., okay, in the Western U.S., including us. Now, there are some archaeological scenarios like Chaco Canyon, where they had a big population of people, and now, I mean, and all of a sudden, all these people disappeared. Now, they didn't die. They didn't find whole bunches of bones and skeletons. The major hypothesis is that they just left because there was no water. And so historically, there have been extremely dry times, and in the Southwest. So, you know, that is inclined to make me a little bit nervous, except for COVID-19, which, you know, probably going to kill me in 6 months, so I won't have to worry about water then. But the bottom line is that Tucson Water Plan, very heavily dependent on Colorado River water. In the future, they plan to recover more effluent water and reuse it, and that's great. But that's not what they're doing right now. And some of this recovery of effluent water is, you know, it's important. It has to be done, because again, water can be cleaned up and reused, no doubt about it. So there's lots of statewide water info. I'm not going to spend much time on these. We've got lots of things to think about. Here's some great websites. You know what, I haven't checked these since last semester, so but I'm assuming they're probably still pretty good. Let's just think. Here we go. Crossing my fingers. Contacting the server for information. No, that doesn't sound good. All right, let's try this one. Oh, wait a minute. Maybe this is a pretty big document. I don't know. Yeah, it didn't seem that long when I looked at it the last time. Okay, that's going to be hovering over us for the next hour, probably, right? Okay. Okay, good. All right, well, better get rid of this one, huh? Let's just look at this one for fun. So that is completely up to date, since it mentions COVID-19, etc. Okay. And this water resource availability. Okay. All right. So sorry about that. I'm up here. Great websites. So let's just go back here for a minute and ask ourselves, how could we conserve water? I mean, what are some ways that you have thought about to conserve water in your homes? That's one of the questions I asked you on the summary sheet is, look, what could you do in your home to conserve water that wouldn't be too inconvenient? Well, I'm really interested to see what people tell me. But some of the things that you could do in your home would be simple things that are as silly as, you know, that old adage, you know, if it's yellow, let it mellow. If it's brown, flush it down. Well, you could not flush your toilet as often as you might have done in the past. You could stop watering plants outside that are big water users and big water wasters and replace those with desert plants that require much less water, and they've adapted to a desert environment so they don't waste water as much. You could decide you're not going to take a 45-minute long shower anymore. You're only going to take a 35-minute long shower. You could not wash your own car in your driveway, but take it to some more efficient place, maybe a car wash that wouldn't use as much water. I mean, if you think about it, there's all kinds of possible ways. I mean, I don't know why I do this. I really don't. But when I brush my teeth, I find that I turn the water on and I just let it run. And honestly, I don't know why. I think I do it because I've done it my whole life. But is it necessary? No. And I'm just wasting water then. Oh, how about this? If you take a shower and you are throwing a bunch of water, polluting a bunch of water by letting the shower run until it gets to just the right temperature, well, you could actually throw your gallon jug in there and collect some of that cold water and use it to water your plants, or use it to feed your animals. I mean, to water your animals. I mean, instead of just letting that water waste, because when water flows out of the shower and it goes down in the sewer, it's polluted and it needs to be unpolluted. And the process of unpolluting it, well, some of the water won't be retained by the city of Tucson, for example. So I am looking forward to seeing what people tell me about simple things they could do to save water around their house that are not super inconvenient. All right, sorry. Conservation, super important. Okay. So now let's just talk for a little about water pollution, the kind of water pollutants that there are. A water pollutant is any physical, biological, or chemical change in water that adversely affects living organisms or makes water unsuitable for desired use. So a water pollution affects human health and welfare. I mean, when you look at the major categories of water pollutants, they can be things like viruses, bacteria, parasites. You know, again, I was just reading in the newspaper the other day that one of the ways they're trying to assess where we stand as far as the COVID-19 virus is by looking for the concentration of COVID-19 viruses in wastewater that comes to the wastewater treatment plants. Just testing, see it, because wastewater, you shed these viruses and they end up getting shed in your wastes, etc., and they end up in the water. And that, so one way to sort of look and go, well, guess what? We are seeing a ton of COVID-19 in the wastewater. That means there's a lot of COVID-19 out there. Or if they said, well, we're not seeing much COVID-19 or very little or none, that would be a great sign. So, of course, human and animal excreta, that's a great word. We were talking about waste products. Organic chemicals like pesticides, plastic, detergent, oil, and gasoline. Inorganic chemicals like acids, caustics, salts, metals, radioactive materials. Oh my gosh, I'm hoping I'm not flushing any radioactive materials down my water supply. But I mean, all of these are things that can cause health problems. Then you go down to ecosystem disruption, sediments, that soil and silt that ends up getting in water, sources of water from land erosion. Talked about that before. Plant nutrients like nitrates, phosphates, ammonia that can cause plant blooms and damage ecosystems. Oxygen demanding wastes like animal manure and plant residues that get run off into water sources. Now, we don't really have big water sources like there that we're tapping into, except the Colorado River water. To say, where did I go? I have to say that some of the canals, some of the Colorado River canals run right through farmland, and they get sediments in them. They run right through farmland, so they get pesticides in them. They run right through farmland where a cow can fall in it or poop in it or whatever. That's the water that ends up coming here, that Colorado River water, which needs to be treated as a result. So these are all things that are real things for us. So when we talk about water pollution, it's common to divide things into what are called point sources, where you can actually immediately identify and go, look, you're polluting the water. Or non-point sources, which are a little bit harder to figure out. So, you know, outside my house, around where I live in Tucson, there's sewers. Water flows into those sewers. Water could flow through your backyard, pick up some kind of pesticide poison. It could, oil from your car could wash off the street and end up in the sewer. And that kind of really diffuse pollutant that happens all over the city. There's like a giant oil spill every day. If you add up the oil that drips onto streets and ends up in water, I mean, it's much bigger oil spill than some of the real famous oil spills. Now, I don't know how it compares to that one in the Gulf, but so those are scattered and diffuse. It's really hard to have a specific location and go, look, this is from that guy's car. But point sources are where you can see an industry, for example, that is adding pollutants to water as part of their cost of doing business. Point sources include things like sewage treatment plants, animal feedlots, industrial wastes. Non-point sources are usually they're things that are cropland that has, some runoff, which could include pesticides, or grazing, so that there's some runoff from animal pastures, and construction sites that they're not deliberately, you can't point to them and go, oh yeah, this is but chemicals end up in soil. In soil, and then sometimes enter the groundwater and enter water sources. So, we've talked about aquifers before, underground water supplies, and how can you add water to that? Well, here's an area right here where this aquifer gets recharged. And if you had a leaking septic tank, or you are dumping trash and that happens to be able to permeate the aquifer, it can pollute the aquifer. And then when you pull it up, well, no pun intended, that water is going to be lower quality than it would have been if that didn't happen. I mean, hopefully you would expect where aquifers are being recharged, that we would be aware of that and be careful about it. But other things like agricultural spraying directly, or underground gas links, abandoned wells, industrial waste, all good examples of point sources. And if you've got a point source, well, you can think, okay, let's address that. But I think non-point sources are almost as important as that, okay? You've got farm and lawn, lawns and golf courses, and just, what I said a minute ago, when it drips out of someone's car and gets on the street, well, we don't have a lot of rain out here, but in some places there's enough rain that washes off. It ends up in water supplies, and that oil is, nasty and has all kind of, breakdown products of oil and stuff in it. Construction sites, deforested land, all those kind of things. Abandoned mines can also be non-point sources. So what about oil pollution in the oceans? Is it points point sources or non-point sources. And I don't know. I guess I would have to say that it's both, right? I mean, there's lots of stuff that pollutes water that just happens to get in the ocean. I remember seeing that video of a plastic bag somewhere inland, slowly but surely working its way to the ocean. It's something like the travels of a plastic bag. I mean, then there are things like tankers that leak and oil drilling assemblies that leak. And then there's, I don't know if they still do this, but I've seen videos of, big ocean liners, which accumulate a lot of trash. They just take those bags of trash and just heave them into the ocean behind them. So the people on the boat don't need to see it. But trailing behind the boat, bags and bags of all different kinds of stuff, which nowadays we're kind of familiar with how polluted the ocean is with plastics that have formed microscopic granules that will end up in fish, all right, or other kind of seafood, and even bigger particles that form things like the Great Pacific Garbage Patch, which is a huge vortex of garbage that people have talked about cleaning up. But so point and non-point sources in the ocean. Again, I just want to mention this because this is in LA, in Anaheim, that they have a wastewater treatment plant there. And so someone flushes their toilet, and there goes their human waste. It ends up in that treatment plant, but it gets processed. We're going to talk a little bit about wastewater treatment in a minute. And in the end, you can actually just take that water and drink it. It meets all OSHA standards. I would guess it's as pure as the water that many people buy in water bottles. And they just, nobody thinks, oh, well, this water that was in this water bottle, it was flushed down somebody's toilet 3 months ago. But in some respects, it probably was. But again, water is water. If you can get rid of all the gunk in it, you can certainly reuse it. It's just how do you reuse it and do you waste it? The Chesapeake Bay restoration, I don't know. When I thought about it, I thought about talking about it, but I actually decided to kind of boom past that. I'd rather talk about wastewater treatment. Oh, and I literally so much wish we could have gone to the wastewater treatment plant. It is really instructive to do that. Now, I don't think they allow tours, certainly don't allow tours now, but they don't allow wastewater treatment plant tours the way they used to. When I started teaching environmental biology 20 years ago, we used to take our day classes and take them right to the wastewater treatment plant. This is when the wastewater treatment plant was kind of uncovered, and you could see a lot of the processes in action. You could smell a lot of the processes in action, and we would stand right where water flowed into the wastewater treatment plant, sometime in the morning usually. So all that toilet flushing that happens when people wake up, it was just proceeding straight into the wastewater treatment plant. And it was kind of amazing to stand there and see that chunky brown water flowing in like a river, and then imagine what was going to happen to it in that wastewater treatment plant. I have to admit, I used to do a cruel thing. I would teach my night class, and I would tell them, look, I know we can't go to the wastewater treatment plant, but I will bring a sample of the water back so you guys can see it and smell it. And I would, people would be like, oh my God, don't do that. But what I would do is I would get a jar in the back, and I would put like some coffee grounds and some Babe Ruths and some chocolate milk and some water in it and shake it all up. And I would have it sitting there on my desk, right? And as it was sitting there on my desk, I would point to it and go, oh my gosh, there's the wastewater treatment I collected earlier today, right? And everybody would look at it and I go, I can't wait. I want to pass it around so you can smell it. And then in front of the class, I would open it up very carefully, like it was toxic, and I would smell it like this and go, oh, wow, that's incredible. And then I would drink some of it. And people just loved it. I mean, well, needless to say, people were freaked out. And then I, told people the real story. But I should have done that for tonight and said I collected it, but oh well. So wastewater treatment is how we take that water that we've polluted and we make it much, much more usable. Inadequate wastewater treatment is responsible for like 80% of human diseases worldwide. There's a huge amount of diseases that are transmitted to people by water. Why? Well, because everybody needs water. And if you are really, really thirsty and you are just really dehydrated, you get to a point where you'll drink whatever water is available to you. And, that Naked and Afraid show that I've talked about before, that's always one of the most dangerous things. They don't give them any water. They have to find water and they need to figure out how to purify it, and here they are in the jungle naked already. And they probably didn't bring any water purification system. They have to figure it out. And, many of those people end up getting sick and tapping out because they get a waterborne disease. So look, let's talk about wastewater treatment, but and because I'd like to just tell you some of the parts, since your own water use will result in this process. But I feel like it's 7 o'clock and it's a good time to take a break. Meaning I need to take a break, so I hope you will be willing to take a break too. Okay, so I would advise that you get up, you stretch, you move around a little bit, get some additional caffeine if that's what you need, and then meet me back here in 10 minutes. Okay, that's the plan. Hi, everybody. I'm back. Give me 1 second and we'll get started again. Are there any questions about anything that we've covered so far? I would, of course, be ecstatically happy to answer it. I love answering questions. One of my favorite things to do. So, if anybody has any questions, let me turn the background music off. Okay, so here's actually a very interesting topic, I think. It's wastewater treatment, how we treat our wastewater. And the reality is that, you know, Tucson produces...
Mr. Mackey,
yeah.
I have a question.
Oh, okay.
There's this concept called plastic shadow balls, and they're used to be on top of a lake. You know, they cover the surface of a lake or any sort of water repository.
Uh-huh.
And I'm wondering, is that like a safe thing? It helps it stop evaporation, but they're plastic balls themselves.
Right. And so they may break down over time. But, you know, I've never really heard of this idea. So, and that's what it's about. It's designed to prevent evaporation. And, well, I mean, honestly, this is one of those perfect... Uh-oh, I don't know if I can do this. Maybe I can. Let's just see. What are they called?
They're called plastic shadow balls, and they save 360 million gallons. I'm sorry, 300 million gallons of water from evaporation.
Okay, well, let's quickly look it up. Plastic shadow balls.
Yep.
There we go. Shade ball cover, advanced water treatment. Oh, let's go to Wikipedia, usually pretty good. Shade balls are small plastic spheres floated on top of a reservoir for environmental reasons, including to slow evaporation and prevent sunlight. Wow, pretty dense, huh? They've got lots of them. And this is in a swimming pool. So it's not, I was having this completely different picture of like, oh, I don't know, some giant ball, but the reality is that you put lots of them in a swimming pool like this. They were designed, I see, to prevent birds from landing on bodies of water, but they also are good for evaporation. Well, you know, here's what I think. I think that it depends a lot on what we learn about their own decomposition, right? I mean, it may be that they're using a kind of plastic that decomposes very slowly. I mean, out here in the desert, you've probably noticed if you leave plastic stuff out in the sun, even if it's floating on water, it can absolutely cause those plastics to break. So I think logical thing would be to sort of look at what they've studied as far as the breakdown of that plastic, and does, you know, they of course out that it breaks down and it takes to break down, and so they replace this every 5 months, and the ultimate goal is to use plastic, which I don't want to say we have an unlimited supply of plastic, but I feel like we have unlimited supply of plastic manufactured, use fossil fuels, and then use those for water, and then who knows, could take thanks, Pablo, for mentioning. Never heard it before. All right, so wastewater treatment. Well, you know where it starts when you fill it, and the water ultimately goes into sewer, and say at the right wastewater treatment aerial photo, ultimately funneled down to a place where it's up, flowing into water plant. Now at the Rogers wastewater treatment, that was designed to handle about 40 million gallons of water a day, and add that to other add that to say the iron treatment plant, the other treatment plants. It generally comes down to this idea that Tucsonans use about 100 million gallons of water a day, which is why when I saw that poster that said 1 billion gallons, I wasn't that impressed, because 1 billion gallons is just like 10 days of no water use. Now, of course, we're going to recycle water and all that. So anyway, right at the entrance to it, there's just a screen designed to take out, and honestly, I've had the opportunity to stare at these bar screens and look at what they're picking up. Which, believe it or not, they pick up clothing. They pick up, they can pick up, you know, pieces of toilet paper and tampons and things like that are just flowing in from somebody's toilet where they were flushed away, and they get collected on this bar screen, and that bar screen gets periodically wiped off by a metal comb that combs it and throws it on a conveyor belt, and the conveyor belt takes it straight away to a dump truck that's there that will haul that stuff away. Now, then, as soon as the water goes to that bar screen, it ends up going into a kind of deep chamber, and that deep chamber is where stuff that's really heavy or heaviest gets settles down. That's about it, and then it gets like up by kind of a screw device that puts it on that same conveyor belt and takes it to a dump truck. And it's amazing, really, because when you look in this dump truck, yeah, you do see a bunch of like human residue and stuff, but you see a ton of things like asphalt, portions of roads that have been, you know, little stones, other pieces of asphalt that have been in the water and have moved along the water, and they're really heavy. There's water here. They finally settle down and they get taken out. They get put in into the water. They are in part of the water plant that's isolated. Seems like it would be kind of nasty stuff. So then the water that you know, it's slowed down into a grit chamber. A lot of stuff settles out. This is the stuff that just is so heavy it settles out. Then it goes over to a sedimentation tank. There's usually more than one sedimentation tank, multiple sedimentation tanks. But what it says primary sedimentation tank, and what that means is that this is designed to just slow water down and allow stuff that's in it to settle or float. And I mean, the bottom line actually got these terms. If once the water gets in this big giant primary sediment tank, which is a big tank, I'll show you a picture of it. You get into this primary sedimentation tank, stuff either one stays sort of dissolved in the water because it's brown, nasty water, or some stuff ends up in float, call that stuff scum, and the other stuff they call that sludge. They're not a skim that moves on top of this tank and skims off the scum and sends it into a place where it could be taken away in a dump truck, or sent away to a digester of some kind, okay, a digestion tank. We'll talk about that. And then this sludge gets, again, scooped up and sent over often to a kind of digestion tank where bacteria actually digest it. Now, there's all kinds of stuff in this sludge, organic stuff, and bacteria will break it down into carbon dioxide and water, or methane and water. And that methane, for what it's worth, that methane can actually be used to run pumps on the plant, like at the Roger Road Waste Treatment Plant. The methane that's produced in what they call the biodigester, it will be digested, and the methane that's produced ends up getting used to power pumps and things. So amazingly enough. Once it's passed through here, it may go through an aeration tank. I don't really think they do that aeration tank at Roger Road, but it was hard to find some exactly perfect document. Then it goes into a secondary sealing tank, which is usually called the secondary sedimentation tank, and more stuff comes out there. And then it all goes into a sludge line that goes down into container of some kind, though at the Roger Road Wastewater Treatment Plant, they will take this sludge, and like I said, they're going to put it in a biodigester that will actually break it down. All right about that. Then after water comes out of here, a lot of the sludge is removed. It goes over a place where it's probably treated with chlorine, either some solid chlorine. It used to be chlorine gas, and it's just like the chlorine you put in your pool to kill organic materials. And then at the Roger plant, they put chlorine to disinfect it. Then they can't release chlorine into the Santa Cruz there, so they have to have a dechlorinating tank. And then they just dump it in the Santa Cruz. I'll show you what that looks like. Now, this first part where you just sort of let stuff settle out and you don't do anything else is usually primary water treatment. In some places, that's basically all they do. If you do this other stuff like aeration and biodigestion and dechlorinate, well, that still pseudonym or anything like that. If you want to basically go toilet to tap, then you put this into a tertiary or third level filter, a really serious filter, kind of like the filters you put, expensive filters you put on the water in your home to make it pure as possible for drinking. And then the water comes out of that right here. Well, this water could be pretty darn clear, could be clean enough to drink. The Roger Road Wastewater Plant does not end up producing water that's clean enough to drink. But in some sense, what the Roger Road Treatment Plant does is, instead of having a tertiary system like this, which is very expensive, they have instead built what they call the Sweetwater Wetlands, which is literally a swamp that's there by the Roger Road Wastewater Treatment Plant, where fluid from this part here goes into a swamp that is filled with plants that help purify water. And it also percolates down soil there and ends up in groundwater. And by the time it does, and they pump it up, it's pretty darn clean, and it meets basic OSHA standards. You know, I drink Tucson water every day, but periodically, it doesn't really sound bad to me. I don't drink Tucson water and think it's disgusting. Now at Pima College, when you run the Tucson water there, I think you're running it through a lot of old pipes, and except for, you know, the drinking fountains, which are purified to one degree or another, I wanted that comes out of the sink classroom there. But the water that comes out of my sink here, I certainly don't think twice about drinking it. And who knows, maybe it'll shorten my life, but I kind of doubt it. It meets the base standards. Now, this is the wastewater treatment plant, okay, from above, obviously. And I want to get myself oriented so that I know what I'm looking at here, but I'm pretty sure that where I'm looking over here, this is the Santa Cruz on the left. And this is the Santa Cruz on the left. And so it's going to be somewhere back here where they're going to actually just dump water into the Santa Cruz. So if the Santa Cruz is there, then the sort of entry point is probably up here somewhere. But you know what? I've got a better diagram where things are labeled. Ah, okay, there we go. Yellow. There's the bar screen right there. So who knows what this is? But here's that, all the bar screen, right? Then these things here, and I'm sorry this isn't a little bit easier to write. This is where they do that primary clarification, meaning that's where they just let the water sit and settle. And they got this dump truck. It's usually posted somewhere over here, so it gets the, you know, kind of weird papery, etc. stuff, and then it gets the asphalt and stuff that came in right here in these tanks. Right, but then the water's taken over to these primary sedimentation tanks. These are big sedimentation tanks that I am wrong. Okay, so there's, let me make sure I label things correctly before I leak, okay? Secondary clarifiers, chlorine contact, dechlorination. We are in the water. Santa Cruz is starting here, you see a river, and here you see no river. Okay, so I'm going to go back and say over here is where that asphalt, other papery stuff like toilet paper and tampons and stuff gets filtered out. Then it goes over here to these primary sedimentation tanks. Okay. Then this is what's amazing at the Roger Road wastewater treatment plant. They have these really tall towers here. These are several stories tall, and they basically take the water from these and they spray it into the top of this tower, and it percolates down through a little ecosystem made of organisms that are happy to remove organic stuff. These biotowers is where living organisms work together to help clarify the water. Once the water comes out of these biotowers, it then goes into a set of secondary clarification tanks, right? Or secondary sedimentation tanks, same thing. Okay, so then it settles again in here, and there's a bunch of new organic stuff to come out. Then it gets pumped from there over to the chlorine. This is like a sort of maze where the water comes in contact with chlorine. And here's what comes in contact with the dechlorination, because they were discovered too much cleaning. And then it gets pumped over and it gets dumped out here in the river. Now, one part that's not indicated here is these things right here that are called digesters. And this is another way that we use biological creatures to use biological to, okay, come on. Shade balls, that was very interesting. Banner, we don't need that. here we are back to here. These biodigesters are kind of amazing. What do take most of the chunky organic stuff that is, of course, part of this process, right? Used by us humans, etc., every day. And they send that over to these biodigesters, which I'm a kind of a pressure cooker. But inside there are bacteria that attack all that organic waste and make one of two things. So I think mainly make methane gas and water. And the methane gas, you can do two things with it if you when you burn it in oxygen, air, normal air, it turns to carbon dioxide and water. So then you release the carbon dioxide in the atmosphere. Oh, does that release CO2 in the atmosphere? Sure, it does, no doubt about it. So it adds carbon to the atmosphere. But another thing you can do with the methane, which is ultimately going to do the same thing, it is natural component of natural gas, and you can use it to run pumps and things on the facility. So you can actually generate a gas that will run some of your machinery there. And so when you run that machinery, you get some of that energy from that methane. And you, again, though, running that machinery means burning the methane, which means it's going to turn into carbon dioxide and water. But the bottom line is that what that results in is that all of this chunky stuff, most of the organic matter that's in there, this chunk stuff, gets digested and reduced down. And nowadays, well, in the old days, what they would do is they would just scoop that out with a shovel and just sit it in some kind of drying area like this, or drying areas, and it would just dry up pretty fast out in the desert and turn into a thick crust that was pretty dangerous, really, because even though these guys digest organic waste, what they don't remove are things like heavy metals or pesticides, arsenic, things like this. So what they used to do at Tucson before people started living here, they would do these kind of drying areas and dry up, but then it would blow away, and I certainly would not have wanted to breathe any of that. Now, I think there was a time when there really weren't many houses around here, but now there's plenty of houses, so they don't do that anymore. Instead, what they do is they get that sludge out, and in a controlled environment, they dry it to 1 degree or another. It's not liquidy, and then they actually can use it as a fertilizer for certain kinds of nothing that you would eat, because again, it could have heavy metals and stuff like that in it. But they can grow things like cotton and what else? Cotton's the one that comes to mind. Of course, they couldn't use to, use in a garden that produces soybeans or any human edible kind of thing. I think cotton was the biggest places where this stuff went. So, you think about it, here you start beginning with this chunky water. You should, I loved watching students, they would get on. So we move on, look at these areas here, and you used to be able to climb up and look at these biotowers. They don't anymore. And then you can stand over sedimentation tank and look at it. You end up here staring out and watch water flow out of it. So, wastewater primary treatment is really.
Mr. Mackey, this is Pablo. I'm having a hard time catching what you're saying. It's freezing and it's cutting in and out.
That's interesting. Are people having that same experience? Anybody else just want to send me a chat and say that having that same problem? Hey, I'm jumping out, Sandy. Okay, I don't think that's because I'm actually. Who knows what that issue is about? I wonder if, let's just do this. Let's get rid of this PowerPoint, which I don't think I'm actually going to get to tonight. To get rid here and see if any possibility that this part of the, I'm going to get rid of this, okay? And I'll get rid of that. And so it's in now, okay? So I guess I'm just proceed, but tell me in 2 minutes reduce any of that load give any of that load help, okay? Because otherwise I kind of feel like about the only option I have would be to start out with a brand new meeting and go to a completely new meeting. So still happening, huh? So wastewater treatment. So nothing has changed. I'm kind of trying to figure out why, I wonder.
Mr. Mackey, this is Sydney. It's gotten a little bit better since you closed a few of the other things. It's gotten a little bit better, yes.
But it sounds like it's not a whole lot better either, huh? Okay, well, you know what? Why don't we do this? Why don't we just end the meeting now? I don't want to kind of go back and try and restart everything for 20 minutes. Let's just end the meeting now. We'll pick it up right here next time, okay? And then, you know, hopefully we won't have those same kind of problems. I really, to be honest with you, I don't know what else to do. I could call IT, but I'm just joking because I couldn't get any support like that. So we're going to come back to this slide next time. I apologize. I really don't know what's going on, but that's going to be the plan for next time. Oh, I sound better now. Of course, now that people are leaving, that's the whole thing, right? So Renee, how do I sound? Better, worse? All right. Well, you know what? I'm already starting to lose people now, which I kind of hate to say we're going to go away and then do it. But you know what? It's not cutting out anymore. Then fine. Who knows why? I'm going to continue. And I have to apologize to anybody who left because I said I'm about to end. Okay, so I'm not ending. Wastewater treatment. Primary treatment is basically getting rid of chunky floating stuff. That's, at the very beginning, that's when you get rid of the chunkiest stuff. Now, secondary wastewater treatment is biological processes. So, for example, one of those is these biotowers that, as I said, it's amazing to see what these look like. They're big, tall tower, about 4 stories tall at least. And water gets sprayed in on the top of them. I'm sorry you can't see this better. It looked better to me when I first looked at it. Gets sprayed in on the top of it. And that water, which is still kind of, gray and chunky water, it works its way down to a whole ecosystem full of water cleaning things. And that can include algae. It can include snails and insects and funguses. I mean, there's a whole ecological community that lives in these biotowers that is part of the cleaning of the water. They used to have to occasionally tell people that they were going to have to shut down part of the wastewater treatment plant because somebody somewhere flushed a whole bunch of pesticides, and the pesticides got into the biotower and killed most of the organisms, and they had to then stop water flow through it, and then they had to try and reseed it and clean it and get it ready to go again. But it's kind of amazing to think that a lot of this wastewater treatment, the more advanced levels of wastewater treatment, is actually done by biological creatures. In tertiary water, this is where you just have a whole series of specialized chemical and physical processes. This is where you could essentially take the water and make it drinkable under circumstances. So where does the wastewater go? Well, it basically goes in two different directions. Here's a picture of it spilling out of the back of the wastewater treatment plant and just creating a river which flows north. If you're standing here and you look to the south, it's crazy. It looks like the desert river, you know, it looks like a desert wash. But you look, did I say south? Yeah, you look towards the north and the river is just flowing away from there like crazy. And it creates a whole riparian ecosystem with trees and fish and you know, turtles and anybody who can manage to survive in that water, which, believe me, that water isn't water I would ever want to drink. I wouldn't want to even swim in it, but it is obviously suitable for creating some kind of basic, you know, basic ecosystem for creatures who can tolerate certain chemicals that are still in it. The solids, though, you know, they go to these biodigesters. Some of them go to the landfill. Some of them go to agriculture. But by the time you go through one of these biodigesters, it's reduced it a lot. But I think there have been times in the past where they've literally had to pay people to take that solid stuff away. They paid farmers to use it as potential fertilizer. And nowadays, they pay too much of it. They end up over to the landfill too. So, but this entire process, other things. Oh, I'm frozen again. The last part of the treatment plant system where we see Sweetwater wetland, which is where they take that wastewater and after they have pretty much treated it, they send it over in marshes. The marsh that's over called the Sweetwater wetland model. This was actually in Arcata, California, but let me see what somebody's texting. You are frozen. Lisa, I only got the you in your message, so I don't know what that means. Of course, again, it could be that you're frozen, I'm frozen. You're doing it again. Okay, well, I don't know. Now I'm going to end class, okay? So look, I'm sorry I'm frozen. I'm going to write a message here that says, I will post the quiz. Oops. Quiz 20 right after class. Okay, I'm probably frozen solid and people can't even understand what I'm doing, but we'll pick it up right here next time, okay? Frozen adios here. All right, see you next time. Turn stuff in, okay?